Welcome to section 4.1. We are dealing with quadratics in chapter 4. So we're going to start you off today with basic graphing of quadratics. If you don't have a graphing calculator, I am going to show you how to do some of that without. If you do have a graphing calculator, get that out now because you're going to want to walk through some of this stuff with us using your graphing calculator. Okay? I'm going to start first with the general standard form, and I'm going to underline this because standard form is important, of a quadratic, which looks like y equals ax squared plus bx plus c, okay? Now, a can't be 0 because if it were 0, we would not have a quadratic anymore. The x squared would go away. So just be aware of that. The look of a quadratic, you are more used to saying a parabola. It's a U-shaped graph. The lowest point on a graph is called the minimum. And there's a picture over here to the right where you can see the lowest point. If I make one in the other direction, where I have the highest point is called a maximum. Okay. And we can see a maximum when the a value is negative, which means it's less than 0. If our parabola, if a is less than 0, the graph opens down. If a is greater than 0 or positive, our graph will open up. We're going to introduce something called an axis of symmetry. This is a vertical line that passes through our vertex. And our vertex is basically our maximum or minimum point. It has an equation because it's vertical. It's going to be x equals, and to be able to find where that passes through, we're going to use this opposite of b over 2a. And we're going to use the values of a, b, and c. Now, I'm going to walk through a couple of examples like that with you, but this is just all of the background information first. Okay? Now, let's take a look at a parent function. A parent function is the most basic function, and so for a parabola, the most basic one is y equals x squared. What I'm going to do is make a table, okay? And when I make a table, I'm going to pick x values, -2, -1, 0, 1, and 2. And for a basic parabola, you could always use these ones. Now, as we begin to shift our parabola around the graph, we're going to change where it goes. But for right now, we're going to start here. Now, I'm going to start plugging in values. At 0, if I plug 0 in, 0 squared is 0. 1 squared is 1. 2 squared is 4. -1 squared is +1. -2 squared is a +4. So what I'm going to do is plot these points. 0, 0, 1, 1, 2, 4. -1, 1, -2, 4. And I connect them in a swooped fashion. And I draw arrows at the end point saying that the graph goes on forever and ever and ever in an upward direction. Okay? Now, the vertex we said was like the maximum or minimum. In this case, our vertex is a minimum because it's the lowest point on our graph, and that occurs at the point 0, 0. The axis of symmetry comes from the vertical line that cuts your graph in half, so you see the mirror image on one side of the other, and that is the equation x equals, and you always take the x coordinate of your vertex, so x equals 0. Okay? Every question we do, you'll need to tell me both the vertex and the axis of symmetry, so keep in mind as we go through that those are things we're looking for. Okay? What we're going to do is look at a couple of different graphs where we're going to make some changes to the look of the graph. So let's move this up, and let's do the two examples that are at the bottom. The first one says graph y equals 1/4 x squared. Now, if you have a graphing calculator, you can put this function in your y equals menu, and if you hit second graph, it will give you the table. For those of us that don't have a graphing calculator, I'm going to make a table. And because I'm not moving, I'm not adding anything to my x, like I'm not moving it left or right, we're going to be able to stay with the points -1, 0, and 1. Now, let's say we didn't have a clue. We didn't know which values to pick. What we're going to say is let's rewrite this quadratic as 1/4 x squared plus 0x plus 0. And I did that so that you can see the value of A, the value of B, and the value of C. If I try to find my axis of symmetry, which we said is the opposite of B over 2A, well, B is 0, so the opposite of 0 is still 0, over 2 times 1/4, and it doesn't really matter what that number is because 0 divided by anything is 0. So what that tells me is I'm going to put a box in the middle of my table for my vertex. And my vertex occurs at 0 something. In order to find the y value, I'm going to plug 0 into my function, and 0 squared is 0, times 1/4 is still 0. So my vertex occurs at 0, 0, and I can plot that point. My axis of symmetry is x equals, and 0 is the number we found that comes from the x coordinate. Now as I pick my other points, I'm going to pick one to the left and one to the right. Ooh, let me actually pick a good point. And then actually I like to go one more point on either side just to be careful. Because this denominator is 4, I'm going to make a -4 on top and a 4 on bottom. Okay? And all I'm going to do, if I have a graphing calculator, you're going to find these are really nice points. If I don't have a graphing calculator, then I'm going to plug it in. 1 squared is 1 times 1/4 is 1/4. 4 squared is 16. 16 times 1/4 is 4. Parabolas are symmetric on either side of the axis, which means that I'll have a y value of 1/4 at -1 and a y value at 4 when I'm at an x value of -4. So I'm going to plot these points. 1, 1/4, -1, 1/4, -4, 4, +4, 4, and I connect my parabola in a curved manner, and what you will see is that it's kind of opened up. It's wider. This transformation is what we call a shrink, okay? And a shrink occurs when the value of A is between 0 and 1. It's 1/4, 0.25. And what I mean by shrink is I'm taking these points and I'm moving them closer to that x-axis. And so it's kind of widening itself as it goes. Okay? We're going to try one more and kind of look at the same type of thing. If I don't know where I'm going to start, I'm going to go 5x squared plus 0x plus 2. And I'm going to start with my axis of symmetry. So the opposite of b over 2a. Well, b is 0, so I have 0 over 2 times 5. Well, again, I'm going to say 0 divided by anything is just 0. So my axis of symmetry is x equals 0. And my vertex occurs at the point 0 something. In order to figure out the y value, I plug 0 into my function. 0 squared is 0, times 5 is 0, plus 2 is 2. So I'll go up to 0, 2, and I have my vertex. Now I'm going to make a table to kind of figure out the other points. So I'm just going to put that up here. You can kind of put it where you need. But in the middle of my table, I'm going to put my vertex 0, 2. And I'm going to pick at least one y value on either side of 0. So one y value bigger is 1. One y value smaller is -1. So I plug in a 1. 1 squared is 1 times 5 is 5 plus 2 is 7. And because parabolas are mirror images, I know that it's going to be 7 on either side. Well, my graph goes to 5, but I can approximate 6, 7 over here, 6, 7 over here, and I get this really skinny parabola, okay? What happened to my parabola, and the first thing I think you see is it started at 0, 0, and it moved up 2. So this plus 2 at the end took my graph and shifted it up 2. Now, we said in the last example, if it got wider, we call it a shrink. If it got skinnier, we're going to call this a stretch. And the way I remember that is when I stretch my arms up, it ends up making a skinnier V between my arms and my head, right? So you're reaching up, you're stretching, and you're taking the points and you're moving them away from the x-axis. You're stretching them higher as you go through, okay? Stretches occur when a is bigger than 1. So the number in front of your x squared is bigger than 1. So this kind of starts us in the mode of parabolas, and we're going to take a couple more on the back side. So flip the page. Now let me start here by talking about vertex. We said you could find the vertex by doing x equals the opposite of b over 2a. We've already talked about that. In your calculator, you can find a vertex too, and I've given you the directions. What I'm not going to do is not do a calculator here. I will show you all of the calculator stuff in class, but those of you that don't have a calculator or would like to know exactly how it works, please try this without, okay? Here's what I'm going to do. I'm going to go back to this example, and I'm going to find it by hand. So even those of you with a calculator, try this without. I need to find the vertex, so I start with opposite of b over 2a. Now, in this case, my a is 2, my b is -3, and my c is 6. So the opposite of b is now a positive 3 over 2 times 2, so I have 3/4. Now this is not going to be pretty numbers, but that's okay. So I'm going to just go right here a second because I think I'm going to need the room, and I'm going to say the vertex is the point 3/4 something, and I don't know what that y value is yet. But to find the y value, I take this 3/4 and I plug it into my equation. So 3/4 squared minus 3 times 3/4, that's supposed to be a 4, plus 6. And I can plug that in my calculator, and what you end up getting, depending on your version of calculator, some of it will be in just a single fraction, some of it will be mixed. I believe you get either 4 7/8, or in a single fraction, you get 39/8, okay? So you can look at it either way. I'm going to write 39 over 8 because I tend to like the single fraction a little bit better. But this is the idea, is you can find the x value, and then you go to your calculator and you find the y value by plugging the x in. Okay? Some of the time we'll ask you just for vertex. Most of the time we'll relate it to the graph. So let's keep going. I'm going to do one example with you, and then I'm going to have you just find information for number 4. So number 4 is kind of an on your own thing. Give it a shot. I will tell you that you get decimals. So in this case, decimals are okay. And I just want to say that so that when you do it, you don't think you're wrong. Okay, you will get some decimals. But let's go through number 3 together. As we look at this, I'm going to start always with my axis of symmetry. And in order to find that, I again take the opposite of b over 2a. Well, b is 4, so the opposite would be -4 over 2 times a is -1, so times -1. I get -4 over -2, which is -2. So my axis of symmetry is x equals -2. My vertex is the point -2 comma something. Well, if I plug in a -2, I have a negative of -2 squared plus 4 times -2 minus 3. When I square a negative, I get a positive 4, but there's a negative in front, so -4 plus -8 plus a -3. -12 and -3 is -15. Now, as I look at my graph does not go down. to negative 15, which is fine. I'm going to change my scale then. Instead of going by ones, I'm going to go by 3. So 3, 6, 9, 12, 15. Negative 3, negative 6, negative 9, negative 12, negative 15. So I go to the point negative 2, negative 15. Oh my goodness, let's stop a minute. As I'm looking at my answers, this is not going well. Take a look. I'm making one common mistake that you guys will as well. What is negative divided by a negative makes a positive 2. I'm going to change this. I apologize for yours, as you're going to have to erase it, right? Let me get rid of these negatives and see, and I'm going to change this. Sorry, guys. As we go through, let's make this a positive 2 because negative divided by a negative is a positive. So my vertex occurs at 2 something. This will be way better. Still a negative 4 plus 8 minus 3. That's a 1. Oh my gosh, much better point. So I have this 2, 1, and I apologize for the mistake, is my vertex. The y-intercept occurs at the value of c. So I go to my function and I say c is negative 3. That means I go down to negative 3 on the y-axis, and I get this point 0, negative 3. Now, I'm going to put in my axis of symmetry because what we talked about is that parabolas are mirror images. So if I go 2 over to get negative 3, I should go 2 over to the right to get negative 3, and I can finish my parabola. The last part is the maximum or minimum value. Value just means the y value from your vertex. It says basically how high or how low does it go on the y-axis. Well, it goes up to a positive 1, so 1 is our maximum value. Okay? Again, I apologize for the mistake there. Give number 4 a try, and we will go through number 4 then in class as kind of the warm-up to say, did we get the right answer or not? So that's the end of section 4.1. Thanks for watching.